Okay, good morning. Welcome to Mr. Morrow's Algebra class. All right, as you can see today, we're going to be talking about percents and their applications. Percents are really, really important. And in order to find a percent, a part, or a whole, okay, we're going to be using either a proportion or an equation. It really depends on preference. I don't like to teach just one way because what works for me maybe does not work for someone else. So there are two ways that I know of. One that I find easier, but again, it doesn't matter what I find easier. It matters what you find easier, okay? So when we're talking about finding a percent, a part, or a whole, you're going to have one, a proportion method. And the way you set up a proportion equation is as follows. Remember, we just finished talking about rates and ratios and proportions. See, this is one of the applications already of proportions. So we have n over 100 equals is over of. N is the percent given, okay? The percent given. And the is over of, a lot of times people get confused with this, but just look at it this way. Is means the part, of means the whole. I never really liked proportions till I got a little bit older and started teaching. Now I really like the proportions, but when I was a student, I liked an equation. In fact, I came up with this because I was struggling a lot, and I said, I got to figure this out. Okay, sorry about that interruption. All right, so as far as the equation goes, they're going to tell you stuff like this. They're going to say 10% of 90 is what number? So we can translate that into words. What percent, that's X percent. And since percent is a part out of 100, instead of having to worry about moving the decimal point at the end, go ahead and write X percent as X over 100 because a percent is something, a part out of 100. So that's what percent. Of we know means multiply. So that's times, okay? That's multiply. The part is a whole. The whole is the whole amount. Okay, the whole amount, that's W. And then is part is means equals, and part is part. P. Okay, does that make sense? You with me there, guys? Okay, now, before I show you some examples of how to work this, let's just have a brief, very brief talk about percents in general, how to write them and their conversions and all of that good stuff, okay? This is really, really Mickey Mouse. I know. I'm not here to bore you, but just bear with me, guys, please. If I have, for example, 32%, please know that that means that I have 32 parts out of 100. 100 is one full whole unit, okay? 100% of something is its entirety, all right? I have 100% of a pizza. That means I have a whole pizza. No slices have been taken out. I have 100% of my notes. That means that every single part of the notes are there. I don't have anything missing. Okay, so 100 is a full, complete unit. 32% is 32 parts out of 100. If you read this as a fraction, does anyone remember how to read this correctly as a fraction?
32 over 100.
Okay, 32 over 100, but how about correctly as a fraction? 32 hundredths. Guess what? 32 hundredths, you already turned it into a decimal. 0.32, right? Okay, why? Because when I go from percent to decimal, I move 2 places to the left. You know how to remember that? If I'm going from percent to decimal, la 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 la. What's the last letter of decimal? L for left. So when I'm going from percent to decimal, la la la, L, left. When I'm going from decimal to percent, isn't there an R in percent? R for right. You feel me? Okay, now, does that make sense, everybody? If I gave you something like this, 3/5, how do you turn that into a decimal? Yes, sir. No. How do you multiply? How do you turn that into a decimal?
We can factor 5.
Okay. 3 divided by 5. You could have multiplied both top and bottom by 20, but what's going to happen when I give you a fraction like 1/7? You can't do it that way, right? So that's good if the denominator is a factor of 100. But if it's not, this is the surefire method. That's why I'm going over this procedure. I'm so proud of you guys. Thank you. 3/5, to turn that into a decimal, goes 5 into 3.0. Bring up the decimal. 5 goes into 30 6 times, so that's 0.6. Now from 0.6, I'm going from decimal to percent, R to the right. That would be 60%. Gentlemen, please, does that make sense on how to toggle? But that means toggle means go from fraction to percent, or percent to fraction, or decimal to fraction, or fraction to decimal. Any of those combos. Yes, sir. Okay, the question was, if it's not an even, pretty decimal answer, and you just have numbers and numbers and numbers, where do we stop? Let's go ahead and just do this for the whole year right now. If it just keeps going on forever and forever, why don't we go ahead and, let's stop at the rounded hundredths place. Now, actually, no. Let's not do that because sometimes you have thousands. Let's go to the thousands. Let's go out 3 decimal places to the rounded thousands. Now, what I mean by that is this. Let's say that your answer is whatever, 0.23587, and it just keeps going on, right? In this case, we're not going to do that. You want your answer to be the rounded thousands place. The rounded thousands place. So first thing you got to go figure out is, what's the 10,000s? Tenths, hundreds, thousands, 10,000s. Now you look at the thousands. If the 10,000s is 5 or larger, it goes up and everything else drops to 0. If the 10,000s is less than 5, then it stays the same and everything drops to 0. So for this particular example, if you were dividing this out and trying to find an answer on the test and you kept going, stop right here at the thousands. You don't need these. From now on, unless I specifically tell you on the test, and I promise I will, round to the millions, then you do that. But if I do not specify, please go ahead and stop at the 10,000s, stop, and round to the thousands. So this answer would be 0.236. That's a great question, son. Does that make sense, everybody? Do the conversions from one to the other make sense to everybody? This is kind of like the fractions and like the integers. It's really important for you guys to know this. We're good? Okay. May I continue? Thank you. Let's go ahead and look at some examples. Finding a percent. What percent of 12 is 2.4? I'm going to do it both ways, okay? The proportion way and the equation way, and then this way you guys can get a feel for what you like better. Let's do the proportion way. What percent of 12 is? Remember the is over of thing, right? How do you think you set it up? X over 100, because we don't know the percent, equals is over of. Now, this is the tricky part. A lot of times people say, but what's the is? Is the 12? Is the 2.4? I don't like to say, oh, it's on the left or on the right, because I could write the question differently. And if you're trained to go left or right, I'm going to mess you up. So what I like to train my students on is think about what the part is and the whole. Remember that the is the part. It's going to be 99.9% of the time. No, I shouldn't have said that. Because sometimes I can increase. So I'm not going to say it's going to be less always. It's the part. Okay? What's getting multiplied to the percentage, that's the whole. What the whole entire equation equals, that's the part. That's the is. Does that make sense? So you just cross multiply, and I got 12x equals 240 divided by 12. So x would equal 20%, because we were looking for a percent. Make sense? Now, let's do it equation way. X percent. You could go like that, but then at the end of all of this work, you got to remember, oh, wow, I got to change it to percent. So I found that to be a little bit of a trouble for my students. So what percent? What percent of 12 is 2.4? Pretty simple that way too. Same exact thing. 12x over 100 equals 2.4. Multiply 100 to both sides. I'm going fast here, guys, because this is just a simple equation, which we know how to do already. And that's 240 divided by 12 divided by 12, and x will equal 20% again, because we were looking for a percent. Does that make sense? Make sense, everybody? Promise? Just out of curiosity, which way do you think you like better so far? Just the proportion way you guys like a lot better? That's fine. That's fine. Yes, sir. Absolutely, sir. I'm not a math dictator. No. Some things I'm gonna have to say, bro, I'm sorry. This is it. It's the only way. But whenever you can do something differently, even if it's not the way I like to do it, that doesn't mean it's wrong, son. Either one of these you can choose. Whatever's comfortable to you. That's what's really important. I don't want you to look at these in the SAT and go, oh my God, what do I do? I'm so confused. No, 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 no. Choose one way. In fact, in your notes, choose the way you like. Okay? Thank you, son. May I continue? Thank you. Type 2. Finding a part. Yes, sir. Hold on. Is this from the last question, or? Okay, what were you talking about, son? Would the top go inside the fraction thing? I have no idea what you're saying. Okay, please come and show me, because I don't know what you're saying. Thank you, sir. Oh, okay. So when you're dividing, thank you for your honesty, and I appreciate that greatly. Okay. Yeah, let's definitely go over that. In elementary and middle school, actually, they mess you up, because you guys, how many of you guys were told, I love this, how many of you guys were told always that the big number goes inside the house? No one was ever told that? Yeah, I know it. I knew it. Don't be ashamed. It's not your fault. That's the way most people learned. The small number goes outside, the big number goes inside. That is wrong. When you have a fraction and you are dividing that fraction, gentlemen, remember that 3 is the numerator and 5 is the denominator. When you are dividing this, the denominator goes on the outside and the numerator goes on the inside, regardless of size. Sometimes the denominator is larger, sometimes the numerator is larger. Thank you for asking. That's a great question, son. I appreciate that. Does that make sense? Okay. Let us continue. 32% of what number, of 8 is what number? All right. Proportion. 32 over 100 equals is, in this case the is x because we don't know it, over of. Pretty sick, right? I mean, in my opinion, I think it's awesome. So let's go ahead and cross multiply. So I've got 256. 256 equals 100x divided by 100 divided by 100. Remember the trick that I told you guys. When you're dividing by multiples of 10, you move the decimal to the left as many places as there are zeros. When you're multiplying by multiples of 10, you move the decimal to the right as many places as there are zeros. Yes, sir. Okay, the question was, can we simplify this fraction 32 over 100? You can, but to be honest with you, Jimmy, I mean, it's 6 to 1, half dozen to the other. If you feel good that way, great. That's just a little extra work. But either way, at the end, you're going to have to reduce it, so it doesn't matter. Thank you, sir. Good question. So now when I divide this, 256 divided by 100 is going to be 2.56. Not because I'm a genius, but think about what I just said. You divide it by 100. So I'm going to move the decimal 2 places to the left for every 0 that I have. 1, 2. Boom. Make sense? Yes, sir. Yeah, that's what I had said. That's exactly what I said with the equation. 32% is 0.32 of times 8 is x. That's exactly what I said to do. That's exactly what I said. Now, some people don't like working with this decimal. So you have the option of going 32 over 100, which is still 32%, times 8 equals x. Either way, when you multiply 30.32 times 8, you got that 6, 1, 2 decimals, 1, 2. So x is going to be 2.56. Either way, bud. Either way. Or you're going to see that 32 times 8 is 256 divided by 100. So x would equal 2.56 regardless. So there's a few ways to skin this cat. The question is here, which way works for you? I cannot decide that, okay? Does that answer your question, son? You sure? That's okay. Putting the 100, 32 over 100, it's the same thing as saying 0.32. Thank you, son. All right, next, finding the part. Do it. 20% of what number is 8? Okay, 20 over 100 and over 100 is equals is over of. Is over of. Boom. We know the part, which is the is. We don't know the whole, which is the of. Cross multiply. 20x equals 800 divided by 20. X equals 40. And that's a number, not a percent. We're good. Or 20%, 0.2 of times x equals 8. Divide by 0.2, divide by 0.2. Okay, a little dividing practice. 0.2, the denominator goes on the outside. You got to make that a whole number, so 1 to the right, 1 to the right. Remember, by the way, a number like 8 or 5 or whatever has a decimal to the right of it, not to the left of it. That's why I moved it 1 to the right this way, and that's going to be 40. Does that make sense, gentlemen? Okay? Nice and easy. Now, that's just one of the applications of percents. Very important application, but there's a few more, and they're not that bad. Okay? Discounts and markups. These are really important. Discounts is when it occurs when you're taking away a certain percentage from an original amount. Okay, when you go to the mall and you see 20% off sale, that's a discount. Markups, you're adding the percentage to the original amount. Now, I'm going to show you one concise way to do it all, and I think it's a lot easier in the end. Okay? Let's say that you're at the mall, and let's just for easy sake, let's say that you have a 20% off sale. Okay? And you want to buy a shirt that's $50. So a shirt costs $50. But I have a 20% off sale. Okay, now, two ways to do this. You could find 20% of 50 and then subtract that from 50. But that's two operations, isn't it? Right? What I'm saying there is you could go 50 times 0.2, that's $10, right? That equals the discount. Now, $50 the original minus the discount, the total sale price would be $40. That's one way you could do it. However, I think it's a lot better this way. The original amount of the shirt, which costs $50, that's 100% of the cost, is it not? It's 100% of the cost. You with me, boys? You with me so far? My discount, am I not taking a percentage away from the original with my discount, gentlemen? Go ahead and subtract that discount. You're taking 20% away of the cost. So at the end, if you have 100% of a value, you take 20% of its value away, what are you really paying? You're paying 80% of the original. So it would be a lot easier to do it as such. Let me just move this down. I'll go back up now in a second. So it's way easier for me to say, okay, it's a $50 shirt. I got 20% off. All right. I'm going to pay 80% of the original, which is decimal one to the right. Boom. In one step, you get your answer. Do you guys see the difference between both methods? Guys, we ain't got much time left. I'm sorry, my man? It seems like the same steps, except not. Here in this first method, you multiplied 20% times 50, found the discount, then subtracted it from the original, okay? Step 2, you find the amount that you're going to pay of the original, and then you just multiply that. It's 6 to 1, half dozen to the other. Again, I'm not going to make you do it one way or the other. You choose the one you like. I personally like number 2, but whoop-de-doo, good for me. What does that mean? It means nothing. What means something to me is that you understand what you're doing. You guys understand what I'm saying? Okay. Markup. The markup has the same exact procedures. It's actually quite funny. But this time, instead of subtracting, you're adding. So let's go back to that shirt that's $50 at Macy's. Okay, they have like a 300% markup, by the way. So let's just say this is the way things work for them. Let's say that they purchase something for, let's say they purchase a shirt, this is Macy's, for whatever, $8. Okay? They add, okay, Macy's adds 300% markup. What that means is 300% of that value, they're going to take that value and add it to the original. So you got two methods again. You got 300%, which is 3.0, times 8, which is a $24. That's the actual markup. That's how much the price is going to go up. Then step 2, $8 plus 24. You're going to pay $32. That's what you pay. That's what you and I pay. It went from $8 and they're going to make $24 off of you on each shirt. So you pay $32. The easier way, in my opinion, is the shirts cost Macy's, okay, the original, they cost 100% of the value. Macy's is going to add a markup of 300% of the original. So in total, we're going to pay 400% of the original. If you do it this way, $8 times 400% increase, which is 4.0, equals $32 in one step. Sir? No, sir. Well, today I guess you could do a proportion. Hey, how would you set up the proportion? Okay, so 300, the percent over 100 equals is, what is the final answer over the of? Yes, that works perfectly. That works perfectly. I think, in my opinion, that's a little bit more work than what you need. But again, yes, a third way to do it. So you could do it where you find the markup or discount, then add or subtract the discount, and you have your answer. You can set up a proportion, or you can find the amount of increase and the total amount of the original that you're going to pay and multiply that by the original amount. Yes, sir. Same thing for taxes and tips and all of that stuff. Okay? Does that make sense, boys? We're good so far? Okay. Thank you. All right, now, percent change. Okay. Percent change. This is an increase or a decrease again, but they're going to give it to you in a different format. Okay? For example, they'll tell you Company A, let's say you work for Company A. Company A earned 1.2 million in 2011 and 3.2 million in 2012. Find the percent of increase. This is real good for business owners and stock markets and all that good stuff. You want to know the percent that it increased. So this is a very, very simple formula. Percent change, triangle means change in physics. Percent change means new value minus old value divided by old value times 100. So this is easy. So this is 3.2 minus 1.2, we're dealing in millions, over the original 1.2. You're going to multiply that bad boy times 100 because you're going to turn that decimal into a percent. Remember, we're going decimal to percent. You move 2 places to the right, which means you multiplied by 100. So this is going to equal 3.2 minus 1.2 is 2.0, right? Times 100, though, is 200 divided by 1.2. So we have 1.2 on the outside, 200 on the inside. I already multiplied the 100, so I'm done there. 1 to the right, 1 to the right. 12 going to the 21 time. That's 8. That goes in 6 times, which is going to be 8 again. So it's going to go 6. And it's just going to repeat over and over and over and over. So in the end, the percent increase equaled 166 and 2/3%. Because you know that 0.66 is 2/3 repeating, right, guys? You promise? Sure. If you're going to do the repeating sign, don't do that. Round it. Go 166.67% then, sir. Thank you, son. Sir. Change, sir. No, you're welcome, son. We still got 5 minutes. I'm just waiting for someone to write this down, and then I'll give you just some little examples, okay? And thank you. You're killing us, man. You got it? No, for real. You sure? Thank you, buddy. All right, man. Let's see what we got. How about if I tell you this? Let's say you're going out with your girlfriend to dinner, and dinner costs, whatever, $53.50. Okay, find your total cost, comma, after, and let's say dinner costs $53.50. That's with tax. Let's say I already added the tax in there, okay? Find your total cost after, let's say you had a good waiter, a 20% tip. Just so you know, this has nothing to do with math, but waiters work hard. 15% is the normal minimum that you should give a waiter, as long as they're decent. If they're good, they go out of their way. You know, they try to make you feel good. It's a hard job, guys. Give them 20%. Let me show you now what 20% is, okay? This is a markup or a discount, first of all? Markup, I'm adding, right? Okay. Isn't it $53.50, isn't that 100% of the total? Aren't you adding 20% of that bill? So aren't you really paying 120% of the bill? So this will be 53.5 times 1.2. You understand how I went from 120% to 1.2, right? Two places left. So then let's do it. 0, 1, 7, skip a space, 5, 3, 5, 2, 1, 4. So your total bill equaled $64.20. What if I want to know now from here, how much did you pay in tip? Thank you. How much tip? You just subtract it. 53.50 minus 64.20, which is going to be 1080? No, 1070. Right? Yeah, 1070. So $10.70. Now, what if I say to you, instead of find your total cost, what if just from the beginning I said, find the amount of tip? How would you do that part? If I just said, find the amount of tip without doing all of this first. Yeah, exactly. If the question just asks, how much are you going to pay if you pay 20% tip, aren't you paying 20% of 53.50? So you go 53.50 times 0.200710 1, 2, 3. Decimals right there, 1, 2, 3. So 1070 equals the tip. Once you add that to the original cost, you have your total bill. Does that make sense, boys? Promise? All right. Thank you very much. And we'll go over some questions now on the worksheet. Thank you.